Hi everyone. Hello. You guys can hear me, right? Someone just let me know in the chat if the audio is okay. Okay, thank you. So I think we'll start at about 2 p.m. So maybe 2:02 p.m. Okay, let's give everyone some time to join. Now we have about 20 people here. So we'll wait till most of everyone's inside. Now begin. Now we have about So those on YouTube, can you guys hear me fine? Is it okay? I'll begin at about 2:02 p.m. when most people are here. In the meantime, you guys can have a quick look at the worksheet. Get ready your foolscap or your paper if you've printed it out. Download the worksheet on your iPad if you're using that. So you can also just go grab water, use the toilet first. I'll begin in 2 minutes. Okay guys, I just put up a poll just to do a confidence check. How do you guys find vectors right now? So please vote. There are 4 options, right? So is it easy? Is it completely like something you can't get at all? Something that your teacher just skipped over and you couldn't really understand? Or is it okay? Or some of you haven't started learning yet? And I see only one person thinks it's too easy. Yeah, most of you all say it's all right or it's not really that good right now. So don't worry, in our lesson today, hopefully we'll give you guys a very good understanding of at least the basics of vectors. Because you'll realize that it's quite repetitive. A lot of the questions are very similar. But also it's a really difficult topic and definitely one of the hardest for O-levels E-Math. So in today's lesson, if you guys have any questions, please feel free to ask. It's a safe space. Don't need to feel afraid of asking any simple questions. It's perfectly fine. So that's for those on YouTube or Google Meet. I'll be looking at both sides. Okay, I think quite a lot of you guys are here. So I'm going to begin with this. I've got to go through this, so bear with me. Just give me like 2 minutes. So who we are at Dojo. So we are Singapore's first fully online tuition center. And it's the 5 of us who are all quite young. So we are all recent graduates from the O and A level program. And we are all also going to be going to pretty decent universities like Cambridge, and NUS, LSE, and King's. So we also have a community online. I'm sure many of you guys are part of us. So thanks for supporting us. And hopefully today will be a really productive and enjoyable session for everyone. So those who are not in any of our channels, just know that in our channels, you can get really good resources like worksheets and notes. And we also do conduct weekly lessons. So in our weekly classes, we provide curated worksheets and notes, just like today's vector worksheet. We provide great cheat sheets and summaries, and also 24/7 WhatsApp support from all the tutors. Additionally, we also have class recordings in case you ever miss lessons. And we also have WA focus revision every time there's a WA or exam. So last year, our students did really, really well. And 2 and 3 of all our dojo students achieved an A1 and O levels. And the A2 rate is also really good. And these are some of the feedback we've received, some of the achievements our students got in the past exam. So these are our tutors. I am right here in the middle. That is me. And I'm the one in charge of EMAth with Dojo. So that's a bit about me. And this is our class schedule. So the thing about Dojo is that since we conduct everything online, we can afford to make the lessons much cheaper. So it's only $60 for a 2-hour lesson. And that's the same for all classes, all subjects. Okay, so I think most people are here. I'm just gonna start the lesson now. So firstly, what are vectors? So this is more for those who are completely new to the subject. A vector is something that represents not just the length of a line. So let's say look at OP here. A vector isn't just a length, but it's a line in a specific length and direction. So you need to remember the vector is the magnitude and direction of a line, basically. Why is direction important? It's because you can have two lines like these, okay? They are same length, but they're in opposite directions. So one could be up, pointing up, and one could be pointing down. So these are different vectors. And a vector is represented in one of these forms. So it can be represented as OA with a line above. So vector A could be OA like this with an arrow pointing to the right. Otherwise, it will be represented by A with a squiggly line or a border A. So typically in exam questions, they will use the border A. But one key takeaway for today is that you always need to put your vectors with the squiggly line below. When you write answers, be very careful. Look at the two examples I've got up here. The first one, let's say vector xy, is equal to A plus B. If you write it with a squiggly line, perfect. But then if you write it with no squiggly line, like the example in red, then it's an automatic -1 mark. So just a reminder to everyone, when you're doing your practice, always make it a good habit to leave your squiggly lines there, okay? Next thing, a column vector is basically when the vector is expressed in a form like this, x over y. And what O-levels and prelim papers really like to ask is the magnitude of a vector. So let's say magnitude of vector A will be expressed like this. So let's say magnitude of vector B will be like this with the squiggly brackets around, with the straight brackets around it. And the magnitude is always calculated as square root of x squared plus y squared. So x and y are the corresponding values of the column vector. Anyone unclear on this? Okay. So how this is derived is basically just your Pythagoras theorem. So let's say we have this vector OP here, right? And OP is A over B. Okay, yeah, no worries. So they really love to ask this question. What is the magnitude of vector A, for example? So let's say here they're asking, what is OP? So you see the question I put here, what is OP? With the straight brackets around it. That is saying, what is the magnitude? So they can ask it both ways. They either say, what is the magnitude of OP? Or they ask, what is OP with the bracket? All you need to know is that you use the formula for Pythagoras theorem. So OP is square root of x squared plus y squared. In this case, OP is A over B, right? So A is X and B is Y. So it's square root A square plus B square. So the reason why I say it's like Pythagoras is because let's look at the line OP here, which is highlighted in red already. The change in X for a coordinate AB at point P, the change in X is A units, right? The change in Y, oh dear, my bracket, the change in Y is B units. You can kind of see it form something like a triangle here, right? Like a right angled triangle. And if you want to find OP, which is the length of the line, the magnitude of OP, which is the length of the line, then that's just Pythagoras theorem. All right, so the length is A square plus B square square rooted. So magnitude in simple terms, it just means the length of the line, the length of the vector. Okay, guys? So this is the 3 marks for vectors. You really need to make sure you know what the magnitude of a vector is and how to get it. It's basically just this one formula here. Okay, guys, so next thing to note is that equal vectors, and equal vectors are when they are same length and same magnitude. Sorry, same length and same direction. So by length, I mean magnitude, okay? So you see these two are the same length, and also they are in the same direction. Only when it fulfills these two criteria, then the two vectors are equal. So let's say this is AB, this is CD. They are definitely not equal because they are different in direction, different in magnitude. So again, magnitude is basically the length of the line. Then what about negative vectors? So in this example, we have AB pointing upwards, and then we have BA pointing downwards. These are negative vectors because they have the same magnitude but have opposite directions. And in this case, BA is a negative of AB. So it's always like that. If you have two lines that are parallel, but the vectors are in opposite directions, then they are considered negative vectors. And you just know that AB will be minus BA. BA will be minus AB. Any questions here, guys? Okay, next part. So how do we get the sum of two vectors? So there's two ways to look at it. Firstly, let's look at the equation here. Okay. If I want to find vector AC, what I would have to do is to take vector AB plus BC. So assuming I have these two values, AB and BC, I can add them together to form AC. So the way you look at it is, you must have a common letter in the middle of the two vectors. So like AB plus BC, that works. And you can form AC, which is the letters on the outside, right? So look at the question I've written here, BC plus CD. Can someone just tell me what this is equal to? Very simple vector question. BC plus CD, anyone?
BD.
Yeah, easy stuff, right? So why does this work? It works because you have C in the middle, right? Of this equation, you have C in the middle. So, okay, we can add them together. What do we get as a result? It will always be BD, the letters on the outside. Okay, then let's say I ask you guys XY plus AB. What do we get from this? Nothing. Okay, basically you can't get anything since it doesn't work. You need to remember that you can't add these two because Y and A are not the same. So this is a very foolproof way of making sure that you know how to solve vectors. Check whether your middle letter is the same. If it is, then you can add them. Otherwise, you have to find a way to form another equation where the middle two letters are the same. So this is looking at it from the point of view of the equation. Okay. Also, we can look at it in this law of addition through a triangle. So you look at it in form of a triangle. Let's say you want AC. Okay, this line in blue over here. I want to get AC. And I have values AB and BC. I can think of it as forming another line going from point A to point B, from point B to point C. So because of this, we know that A to B plus B to C is equal to A to C. It's like having two different pathways, but the start and end points are the same. So what I typically tell my students to do is look for the start point. Let's say you want to find AC. We find the start point of A. Okay, then we find the end point of C. End point of C. Then I know that I want to get this blue line going rightwards. I can get this blue line by going from point A to point B, then point B to point C. That's why AB plus BC is also equal to the blue line of AC. Okay, Adriel on YouTube. Yeah, it's a similar idea as matrices. So like matrices, your middle numbers must also be the same, right? To know whether your matrices can be added together. So similarly, let's say here, your B must be common in the middle, then you can form AC. So it's just like a similar idea. Please not repeat the part about triangle, right? Dia. Yeah, so let's say, this is a simple example, but let's say the question is a funny shape, like you also have a vector going down here, you have a vector going up here. Then the question is asking for AC, right? To get AC, I'm going from start point A to end point C. Do I take the red pathway or would I want to take the green pathway here to go from the start point to the end point? Adriel, don't worry, we'll be going through questions like that later. After I get through the notes. So yeah, we want to take the green pathway, right? So we know, okay, that means that AB, which is the part 1, plus BC, which is the part 2, is equal to AC, right? Because you end up at the same endpoint. Remember, AC is just going from start point A to end point C. Because the line is just, use another color. The line is this purple one, right here. Any questions? Any further questions? Yeah, so later we'll do more practice, don't worry guys. If it's still a bit unclear, especially those who are newer to this. Actually, let me leave this here so I can send you the worksheet. Don't worry if you can't copy everything in time, I'll also just send you the worksheet after the class. So now there's a parallelogram law of addition, but it's a similar idea. Where you see, let's say you want to get AC. You notice there are other possible pathways you can take, right? Correct? So let's say you know that this blue line is vector A followed by vector B. Then I would know that AC equals to vector A plus vector B. This is basically the idea of adding up vectors. Now onto the part where it's a little bit more tricky, law of vector subtraction. So similar triangle, but in this case, let's look at it. We want to get CB, right? Let's say we're finding CB. And we have this vector AB equals to A and AC equals to B. Can anyone tell me what is vector CB in terms of A and B? Those who kind of know what vector law of subtraction is. So just send in the chat those who are more familiar with this. So you say B plus A, right? So this is a common mistake because we previously mentioned, oh, you can take another pathway, right? So you're gonna go B, then you go up to A. So Adriel, you say A plus B. Yeah, no. So yeah, exactly. You need to remember that vectors direction matter. So in this case, it cannot be B plus A because the vector B is pointing to the right? So let's see the start and end points, okay? Start point at C, end point at B. We want to go left. So we go from C to A, right? But our vector B is pointed the other way. So yes, correct, it'll be minus B plus A. Because it's the other way, it is minus B. But A, how come you're saying it's minus A? No, it's not minus A because you're going from A to B, right? So actually that aligns with vector A. So the answer would be minus B plus A. Okay? Any questions here, guys? So Irvin, if you're in the WhatsApp chat, for those who sign up for the crash course, the notes are there. I'll send them earlier. Okay, so yes, remember your squiggly lines as well. So let's look at the question one more time with everything erased. Let's say we know the value of AB in purple. We know the value of AC in blue. To get CB, it would be minus AC, which is the blue one, plus AB, right? That's why we can rearrange it and get AB minus AC equals to CB, which is what is stated here. So this is just a bit of explanation for why this is here, AB minus AC equals CB. So if you're okay with this, can you give a thumbs up so I can make sure that most of you are okay? Any questions, let me know. Okay. Osaka, Japan, why? Because as mentioned earlier, we need to take a minus AC because we are going the opposite direction, right? We have a minus here because we want to invert the blue line to become pointing left, right? So minus AC would be this red line here. Does that make sense? So you see, the red line plus the purple line, we are going from start point C to end point B, right? Therefore, CB is okay. Very good, awesome. So hopefully everyone got this now. This is like your absolute basics of vectors, and I know a lot of students struggle with this, so I wanted to spend more time on it. Those more advanced ones, don't worry, there are some really tricky questions later. Okay, last part here, very simple. Just think about matrices. For any two vectors, let's say A and B, we can add them up together. So let's say vector A is PQ. So okay, I'll give you guys an example. A is 1 over 2. B is 2 over 2. What is A plus B? So you can just write it like 1, 2 in the chat, whatever the answers are. It's just like adding your matrices together. Your top part you can add together, the bottom part you add together. Yeah, easy stuff, right? 3, 4, exactly. So if anyone's a bit confused, let me just quickly write it. A plus B equals 1 over 2 plus 2 over 2. That is 3 over 4. Actually, is my handwriting okay, guys? I know I scribble a lot, so hopefully you guys can see. If there's any like not readable word, please let me know. Irvin, yes, I will send the annotated notes. Okay, oh yes, I know my handwriting is awesome. So next part, scalar multiple. Let's say we are dealing with a vector A here, and I times 2, okay? So all these words, I think just ignore if you don't get it. Let's say I want to times 2, have 2A. Very simple. I just make the line 2 times longer. Okay, so it's very simple stuff. If I want to get half A, then my line is just half the length. The only thing you need to remember is that it's going to be parallel. Because remember, vectors are magnitude, or they have a magnitude as well as a direction. So the scalar, which is whether you times half or times 2, it affects the magnitude. But will the direction get affected? No. Okay, so it's always going to be parallel when you times it by 2 or 4 or 6 or 20. Then if you times it by a negative number, so k less than 0 means a negative number lah. Okay, negative number. What happens is you invert the line. So let's say originally it's the red line vector A. If I times by -1, it faces downward instead. Then it becomes -A. So originally, let's say I have vector A in red, then I multiply by -2. So I get 2 times length, but I face the other way. I start going down because there's a negative number. So you just reverse the direction. Easy stuff here, right? So next thing, collinear. Okay, don't worry, getting to that soon. Sounds confusing, but actually very simple. First thing to understand is what's a parallel vector. I think you all know, right? Parallel means two lines that are going in the same direction. So let's say you want to prove that two lines are parallel, you have to do something like this. So let's go to a question. AB is 2A plus 3B. CD is 6A plus 9B. If I want to prove that they are parallel, I want to show that AB equals to KCD, or CD equals to KAB. So maybe I make it like this easier. KAB. K is basically literally any number. So let's look at this question. CD is 6A plus 9B. We can factorize the 3 out, right? So you see, I factorized 3 out. I end up with 3 times 2A plus 3B. Can you notice that 2A plus 3B is the same as AB? That's why we know that CD is equal to 3AB. So in this case, 3 is the K, right? The number. And if you can form this equation, then you know that they're parallel. Any questions here? Oh, and one more thing to note, you literally need to write this sentence out in your answer. This is what will help you get your answer mark. So maybe you can leave a star here or something. Just remember that for proper presentation, it's good to write the entire sentence. Okay? So please highlight it, write a star or something, because this is another common mistake. Students will just end up with this, but then they don't answer the question, stating that it's parallel. So very simple example. Let's say xy equals to a plus b. AB equals to 2a plus 2b. Are these two lines parallel, guys? XY and AB, are they parallel? Yes. Yeah. So let's say I make it 2a plus 4b. Would it be parallel then? Are XY and AB parallel? No, exactly. So you must see whether you can factorize it to make them parallel. Yeah, Israel, they're not parallel. So in this case, let's say I factorize, I'll get A plus 2B. So no, not parallel. So this is another very, very common question. Okay, so this one should be 3 marks for you all. It's really free eats. Yeah, you can factorize the two. So just because you can factorize the two doesn't mean it's parallel. You must make sure that this is equal to this. See my two highlights? It is not equal to 2xy, right? Yeah. So it's not about whether you can factorize or not. It's whether it is equal to like ab times something or xy times something. In this case, xy times 3. In this case, it's not possible here. So guys, this is really free eats, free marks. You can't lose it. So let's say this comes up in an exam, 2 free marks. The other one is your magnitude type of question. So just a quick refresher, remember magnitude, you follow this formula. Square root x squared plus y squared. Another 2 possible free marks. That's 4 free marks for O levels. If you can just do this. Okay? So let me clean everything up a bit. It's a bit messy. Oh dear. Next thing is about collinear points. So sometimes you guys will see this word. Can you prove that points A, B, and C are collinear? Then you don't know what collinear means. But what it means is that they lie on a straight line. So very easy. You see the diagram I've drawn on the right? I mean the little sketch. You have 3 points A, B, and C. And they are on a straight line. So that is what collinear is. Now, how do we prove that they are collinear? So step 1 is to prove that AB is parallel to BC. Or you can prove that like AB is parallel to AC. Some version of this. If you prove that they are parallel, then we know that they're going the same direction, right? But how do we prove that they are collinear? You need to prove that B is a common point. But in O levels, the question will usually tell you that B is the common point. So all you need to do is to say that they are parallel, prove that they are parallel, and say that, oh, because AB is parallel to BC and B is a common point, A, B, and C are collinear. So you have to write a sentence like that to explain. So example, since AB is parallel to BC and B is a common point, A, B, and C are collinear. So, Osaka, Japan, just now you say you don't understand collinear questions. Does it make sense now? Aisha, how to show B is a common point? Basically, in O levels, right, the question usually tell you that already. So the question will be saying like, oh, point B is a common point. Point B is a common point, and how do you prove that A, B, and C are collinear? Or they say, how do you prove A, B, and C are collinear, assuming that B is a common point? It usually be stated in the question. That means that your part 2 here is already done, right? You just need to state it in your answer to explain. Then the work that you need to do is to prove the first part. Does that make sense? So the second part of this, the question usually tell you already for O levels. It's not so advanced. Part 1 is proving of parallel lines. So it's similar to what we did just now. The only thing you need to do is in your answer, you say that B is a common point. You just need to make sure you state it to show that it's collinear. Does that help you all? Okay, that's great, that's great. So if you see collinear in a question, don't get stumped or confused. A lot of students worry, but it's just basically what we did just now, proving of parallel vectors with the extra step of saying, oh, point B is a common point. That's all. Okay, so a bit of recap of what we have done. Very basic vector question. Oh, okay, you don't get it. So, what do you not get? Like why they are collinear, is it? What if they never say common point? Then you would have to prove it based on a question. But typically, it wouldn't be so challenging. And if you have to prove the point B is a common point, it should be quite straightforward. Because the tricky part is always the first part. The first part is usually the tricky part. So I don't have time to go through every single example for collinear question today. Unfortunately, we only have about 2 hours. So we'll focus more on proving of parallel vectors, and there are plenty of other questions to cover. Okay, just take note that usually the trick is to understand that they must be parallel and having to prove that they are parallel vectors. And the point B being a common point is usually something that they'll tell you in a question. Sometimes they may not, but they will usually be quite straightforward. So collinear means they are on a straight line. So let's say this is point A, point B, point C. Collinear means they're on a straight line. Okay. Then for us to prove that this is collinear, we must do 2 things. Firstly, show that they are parallel. You see, if they are parallel, then we know that, okay, AB and BC are in the same direction, right? But look at what I've done in blue. It could be like this, right? How do we know that they are one straight line? The way to know that is if we know that B is a common point. You see, if B is a common point, means this is connected to this. So therefore, it has to be collinear. Is there any specific part you don't understand? So we can prove, let's say AB parallel to BC. We can also prove AB parallel to AC. We don't have to prove both of them. It's like either or. So let's say we know that AB is parallel to AC. Okay, so let me just give an example. We know A to B is parallel to AC. Okay, so there's something like this, parallel. Then if you prove that B is a common point, or like B is between A and C, right, then B has to be here. So you don't need to prove all, you can prove like AB parallel BC, or AB parallel AC, or you can prove BC parallel AC. But typically it would be the first one. So like 8 times out of 10, guys, you just need to do this. Prove that AB is parallel to BC. Okay? Okay, if there's nothing else, y'all can try the question 1 here. So it's a very simple question. OA highlighted in red here is equal to A. OB in blue is equal to vector B. So I'm going to give you guys about 1 minute and I'll go through it for both parts 1 and 2. So anyone have any questions about the previous parts? Like parallel vectors, sum of vectors, difference of vectors, what are negative vectors, what's the magnitude of a vector? Any questions, please voice out now before I go through question 1. The goal of today is to make sure everyone in this call has a super solid foundation of vectors. And like all the 3-mark questions, everyone can get it at the 3-4 marks. That's the main objective. Second objective is you'll understand the tricky questions. get a taste of how challenging vectors might be. So we'll do a bit of that later. But firstly, everyone needs to understand the basics. Okay, those who are done with part 1 and part 2, just give a thumbs up so I know when to go through it. Wow, 2 people, oh, 3. Okay, you're fast. Okay, I'm gonna start to go through for part 1 first. So BP is this green line here. Based on the question, we know that OP is equal to 3OA. So OP is this long line here, right? This is like 3 units. Then OA is 1 unit. That means that AP will be 2 units, right? So how do we do part 1? We would have to start at point B and end at point P, right? That is what BP is. Based on what we have vectors B and A. So what I want to do is go down, oh dear, tech difficulty, sorry. Okay, go down from B to O, then go from O to the endpoint P, right? But you see, vector B is pointed in the wrong direction. So it would have to be minus B instead. Then we see there's vector A here, but that doesn't go all the way to point P, right? So we need to plus 3A, because this is 1 unit, this is 2 units. So actually A to P will be equal to 2A, where A is a vector. Okay with part 1? So next thing, the question said that 4BQ equals to PB. So this is point B. BQ is equals to 1 unit. BP is 4 units. So this part here will be 3 units. Right? So we know the total is 4 units lah. So to get QB, from point Q to point B here, this black line, we just take 1 over 4, negative of 1 over 4 of BP. So to make it a bit more clear, maybe I'll erase it now. Just now, we had BP from part 1. Right, this is minus B plus 3A. We know that BQ is 1 unit, BP is 4 units, right? So for a vector QB going left in blue, we would have to take 1 over 4, because it's 1 over 4 in length, right? You see, Q to B is the blue part, is 1/4 of the red. And the reason why I take a negative, because they are opposite directions. That's why it is minus 1 over 4. Yeah. So any further questions, guys? Okay, don't worry. Again, first we look at what we got from part 1, right? We got BP, which is this red line, correct? Drawing minus B plus 3A. Yes, I'll be sending a notes later. And Jingyi, hold on. So BP is minus B plus 3A. Everyone got this, right? Then we want to get QB. So let's look at QB. Start point is here. End point is B, right? So we are going this way now. Going left. So why is it 1 over 4? Because this is 1 out of 4 units. So for the length, it is 1/4 of BP. Correct? The direction, negative of BP. So if I combine both, that's why it is QB equals 1 over 4 times BP. Does that answer your question? Okay, then for part 1, why is it not minus B plus 4A? Because part 1 was finding BP, which is a red liner, it will not be 4A because AP is 2 units. The question said that OP equals to 3OA. OA is this. OP is the entire line. So basically the entire line OP here is 3 units. That's why we know that, okay, this part is 1 unit. The next part is 2 units. No, this is not collinear points. This is like the vectors sum. The sum of vectors type of question. There's nothing about collinear points because we're not trying to prove that they are parallel lines, right? This is what we did earlier. Sum of 2 vectors. Don't get mixed up. Then, okay, someone said, can I find BQ, then QB? Yeah, if you can find BQ, then you take minus BQ equals to QB. That will work. Any questions, guys? Okay, I'm gonna move on. Okay, this is something that a lot of schools don't teach. So if it's completely new, don't worry. It's more of like an application of vectors, but it's a very common question actually. So firstly, let's say we have similar triangles of A, B, C, and a big triangle A, D, E. How do we know that they're similar? Someone just let me know in the chat. It's a revision of the previous topic. How do you know these triangles are similar? Yeah, right. The angles are common. So let's say this is equal to this. This is equal to this. They have a common angle here. So all 3 angles are actually the same. That's why, yeah, it's AA, similarity, right? So very good, you'll remember this. Now, there's something called the ratio of the areas. So let's say we know that the length of ABC. So okay, let me highlight it to make it clear. Let's say we know the length of yellow triangle is X. Okay. We know that the length of the big triangle in green is X plus Y. Right? This is the length. The ratio of the area will be the ratio of the lengths squared. So length 1 to length 2 is, let's say, X to X plus Y. The ratio of the areas will be X squared to X plus Y squared. So this is just a general rule, guys. If you know the ratios of the lengths, we can find out the ratios of the area. Only if they are similar triangles. So let's say I'm telling you x is equal to 2 units, okay? Then I'm telling you that this is 3 units. What is the ratio of the small triangle to the big triangle? Area ratio. Why is it 3/2? The length of the yellow is smaller. 2 to 5. Anyone has any other answers? So let's see the length ratio. Length of yellow to length of green is actually 2 to 5. 2 plus 3. Yes, Ryan, you got it right. Then area ratio, let's say A yellow to A green, it is 2 square to 5 square. So my point is that to get the area ratio, you just have to square the length. So that's equal to 4 to 25. Any questions, guys? It is not 2 to 3 ratio for the length because this is not the length of the big triangle. So no, it's not 2 to 3. And remember, for area ratio, it is not the same as the length ratio. You need to take the length ratio squared. Then that becomes the area ratio. Okay. Then if you look at it, it makes sense, lah, right? How can the area ratio be 2 to 5? Any questions, guys, about this? Okay. If you're okay with this, give a thumbs up. Let me see if everyone's okay. Okay, good, 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 good. Okay, last call. Any questions here? This is quite important. Okay, awesome, guys. Let me try and make this smaller. My page is getting too messy. Okay, so now the next part, triangles with a common height. So let me highlight the triangles again. Let's see, you have A, B, C, and then you have A, C, D. Okay, so you have one yellow triangle and one green one. If they have a common height, this will be the area ratio. So firstly, why do they have a common height? Because let's say the yellow triangle height is here, right? This is the base, X, this is the height. Green triangle, this is the base, this is the height. So actually the heights are equal. And let's say we want to find the areas of these in a fraction, right? So look at this part over here. To find the area of triangle, we can use half times base times height, right? In the numerator and denominator, they both have half. So as you know in math, you can just cancel, right? Make it easy, cancel yourself. Then the height is also the same, right? So I cancel height also. So if the triangles have a common height, right, the ratio of the areas is just the ratio of the bases. So in this case, they're talking about ABD. So ABD is the entire triangle in pink lah. That's why it's X plus Y. But let's say I'm talking about the yellow and green triangles, then it will be just X over Y. Yeah, Adriel, correct. Area ratio, you just square the lengths. Exactly. So if you're okay with this, thumbs up. Then we can move on. And any questions, please let me know now. We'll go through a practice question like this later. Okay. So guys, I may have to speed up a bit for time. You try and cover as much as you can. I only have about an hour left. So question 2, you guys can try part A first, and I'll go through it after 1 minute. So this is the last basic question. After this, we'll go on to some hard or more tricky prelim questions. Okay, someone let me know what you got for part 1. What is XY? Okay, so XY is this one here, right? Yeah, actually XY is just opposite of OW. So you see OW in blue. The question already told me it's 4A minus B. XY, is it the same length? XY and OW. Is it same length? Yes, right? Same magnitude, opposite direction. Therefore, XY is equals to minus OW equals to B minus 4A, or 4A minus 4A plus B. So reminder everyone, if you didn't put the squiggly lines below your letters in your working, you just lost the mark. So be very careful again. Because you see this question, I know they put it in A and B, but they bold it, right, to represent vectors. For us, when we write it in our answers, we need to put the squiggly line to show that we know that they are vectors. Next one is WY. This purple line here. No, not true, right? What do we know of parallelograms? Let's remember. For parallelogram, all we know are the sides are the same, right? And same, and they are usually parallel. But then in this case, when it comes to vectors, they can be opposite directions. So just because it's a vector topic doesn't mean that all parallelograms become opposite direction. It depends. Because let's say they give you the value of yx. Sorry, they give you the value of wo. Then we already know that that's equal to xy. It depends on what the value is, like what values they give you. The question is the one that stated that, see, they're pointing up. And the right side, we know it's pointing down because of the question asking for xy. It's opposite direction because you see xy, we start at point x, and point y. Right, so naturally the arrow is pointing down one. Then the question saying that OZ is pointing up. So they are in opposite directions. Okay, so someone let me know your answer for part 2, A part 2. 5A minus 4B. 5A minus 4B. Ah, okay. So again, let's look at what we've got, okay? We want to start at W and we end at point Y, right? So what path can we take? Based on the question, I would want to take this path going down to point O, followed by going up here. Yeah, exactly. So minus 3A plus 6B, because we have to take the minus of this. The arrow is pointing the wrong way. So part 2, WY equals to minus 4A minus B plus A plus 5B minus 3A plus 6B. So remember your squiggly lines when you're working. So Guna freak. Do you understand why it's not 5A minus 4B? Yeah. I can't believe I just had to say that. A plus 5B for part A, part 1, A plus 5B. Oh, but you see, A plus 5B is this line here. For part 1, they were asking for XY, which is this red line going down. So we use the opposite of OW, because these are the ones that are parallel, just in different directions. They are parallel, different direction, so we can just take the negative of OW. They are negative vectors, remember? What do you mean, what about minus 5A plus 6B? OW plus WY. Huh? OW equals OW plus WY equals to minus OY. So let's say you do that, what, for A minus B, OW plus WY equals to OY. Why would it be negative? You see, let's say you're talking about OW then WY. Your start point is O, your end point is Y. So it is OY, not negative OY. So you wouldn't get negative OY. Remember when I mentioned the sum of vectors earlier? OW plus OY is OW plus WY. It works because you have W in the middle, but you end up with OY. Because that is what's at the side. You don't get minus Y. Okay, let me go through the next part now. Is WY parallel to OZ? So that is this line in red as well as this line in blue. So you will give you guys a bit more time. Try and think what are OZ and WY. How do we prove they're parallel? Yeah, excellent. Part part 2 is 12 units. Yes, exactly. So let me just show you how to make sure the presentation's all right. So we can write it as C of WY equals to this. Then we write it as equals to 3 minus A plus 2B equals to 3 times OZ. And you just write the statement. Okay, so for the last part now, who's done with the last part? Question B, part 2. Okay, then you'll take another minute to finish up the last part. It's in the question, usual. OZ equals minus A plus 2B. Okay, 4. Someone said 4. Any other answers? Yeah, actually it's 12. So let me highlight the triangles. So we have triangle OWY. So OWY is this one here. We also have triangle OYZ. So it's like this. We know that the OWY is 36 units. So remember remember that there's something I mentioned about triangles with common height, right? See this question? These two triangles, if you notice, they share a common height. Therefore, you can use what we learned earlier. So area of triangle OYZ over area of triangle OWY equals to half. OYZ is this one, the base is what? OZ, right? Times height. OWY has a base of WY times height. So remember, we can cancel out the half, cancel out the common height. Now we just need to find the ratio of OZ to WY, which is 1 over 3, based on the previous part. So area of OYZ equals to 1 over 3 times 36 equals to 12. You can see that it's a common height, right? Because you see, this is the tip of the yellow triangle. Okay, I'm gonna draw the cross on the tip. This is the tip of the other triangle. You go from the tip to the base. These are the two heights. See, they're common. They're the same height. Because the question said area of triangle OWY is 36 units. Okay, so maybe I break it down a bit more simply. So area of OYZ over area of OWY equals to 1 over 3, right? Then we know that area of OWY, this is 36 units, correct? So I can just replace the denominator with 36, correct? Then we bring it over 1 over 3 times 36. That's why it's equal to 12. We don't know what the common height is actually. We just know that this is the height of one triangle, that is the height of other triangle, and they're the same. Alright, so actually we don't need to know what the height is. We just know that they're the same. So I cross and cross. I mean the height of the triangle is from the base to the top, right? So those are the two heights. And visually you can also see it. Okay, awesome. You understand it now. Guys, any other questions? So I'm afraid we have to skip this one. This ACSI question, we have to skip it for now. Let's try the AHS question. How do you want to do it by algebra? I mean, if you used algebra and want to check if that worked, you can send me a photo of your work on WhatsApp. I'll have a quick look. Yeah, so guys, we try this question first. AHS 2022 prelim question. Yeah, sure. No worries. So if anyone is completely lost, if you want to find the coordinates of of B, you need to look for the vector OB. Because imagine x and y axis, okay? This is the origin O, this is point B. If I know what origin to B is, this vector, then I can know what the coordinates are, whatever they are, x and y. Then you see here, they said coordinates of D is 6, 2. That means that OD is 6, 2. So it's a relationship between column vectors and coordinates. Who's done with part A? If anyone is done with all three parts already and is a bit ahead of the class, feel free to attempt the questions below. Some of them are more tricky. Yeah, part A, 2 comma minus 6. So let me explain why. So what we want to find is OB, right? OB is equal to OD plus DB, right? We have value OD and we have BD. So it's not the same as DB, but we can get DB by taking minus BD because we are reversing the vector. Therefore, 6, 2 minus 4, 8. That gives me 2 over minus 6. So I want to point one thing out. The question here asked for coordinates. So if you leave your final answer as 2 over minus 6, they wouldn't give you the mark because what you just wrote is a vector. You're talking about vector OB, right? So this is another very, very, very common mistake for O levels. If they're asking for coordinates, you need to write it as B 2 comma minus 6. So the answer box, let's say is the answer box. You need to write it like that. And for part B, I would recommend drawing a sketch of a parallelogram. I think that would help. Okay, Israel, don't worry. Do you understand part A? Anyone has confused about part A? What do you not understand by part A? Remember, that's how we add vectors, right? We get OB by adding OD and DB. So you can do this because D is common. We end up with OB. Part A, there's not much to visualize. Actually, you just need to remember that this is how we add up vectors. And we just need to know that when they say you have a coordinate of D, we know that that is OD. If they are talking about coordinate of B, it means actually you're asking for OB. Because if we have a y and x axis, let's say this is point B, is the origin, OB would be this straight line. Then let's say this is point D, random point lah. The purple line would be point D. Purple line will be vector OD. Now for part B, vector BC. So first thing you do is to draw this part B. No, it's not minus 3, minus 1, Guna freak. You have to sketch out a parallelogram. That will help. So let's say you have A, B, C, D. Something like this, okay? Then we want to find BC, which is this straight line. How can we do that with values that we have? Yeah, it's opposite of AD. So what I would do is, okay, start point is B, end point is C. Based on the question, we already have point BD, right? And then we have vector BD. So we can go down this path. And then we need vector DC. What is vector DC? It is actually the same as AB because they are opposites of a parallelogram. So that is minus 1 over, vector DC is equal to vector AB which is -1 over -5. So if you want to get BC is equal to BD plus DC equals to 4 over 8 plus -1 over -5. 3 over 3. That should be your answer. Guna freak, do you understand this? Any questions, anyone? Excellent. So last part, part C, easy stuff, right? CD is opposite of AB, right? It's a parallelogram. So the magnitude of CD, remember we need to write this square bracket, which is the modulus CD equals to modulus AB. So how do we do this? Remember, it is just this simple formula. And your answer should be in 3SF. Is everyone okay? Okay, thumbs up if you're okay with this question, and I can move on. So today we might end a bit later than expected because there's still quite a bit to do. So if you all want, you can stay past 4 p.m. Don't worry, I'll extend the class by a little bit. Because the last two questions are the trickier ones. So let's look at this question. Paper 2 question. AB is 2P, AC is equal to 3Q. T is a point on BC where there's a ratio of 2 to 3 here. So CT is 2 units, TB is equal to 3 units. Question A, part 1, find BC, which is this line here. Okay, not very well drawn. Let me redo. Okay, can I just have a quick confidence check again? So you feel like from the start of the lesson to now, you find vectors a bit easier, or you have managed to learn something or a few new things, give a thumbs up. If you feel like it is completely like nonsense, I'm just yapping, you don't understand a single thing, put a crying face and let me know what's wrong. Do you have any crying faces? Any questions? Okay, good. Yeah, you're new to the topic, right? I think I saw you say earlier you haven't really learned vectors. Yeah, so it's okay. We are going at quite a fast pace for someone who has no idea what vectors is. Usually what we did today will be 4 lessons in school, maybe. So don't worry if you're still a bit lost. After class, maybe take some time to digest. If you have any questions, you guys can also text me simple questions after today's crash course. I'll be more than happy to explain a bit more. Okay, so let me go through the first part, yeah? BC. So again, start at point B, we're ending at point C. Based on the values you have in the question, very simple, right? We need to go down this path, B to A, and then A to C. So BC is equal to minus 2P. We're going the other way of the arrow, right? So we need to reverse it with a minus sign. Plus 3Q. The arrow is in the same way, so we just add a 3Q. Easy stuff. This is your answer. As for part 2 of question A, we're looking for TC. So instead of the whole entire blue line of BC, we just want this section of TC. So for part 2, guys, it is just 2 over 5 times BC, right? You see, it's actually the same line, but it's a shorter version. The black line is a portion of the entire blue line. So 2 over 5 times BC equals 2 over 5 times minus 2P plus 3Q. That is the answer. Because we have the ratio of 2 to 3 here. The entire length will be 5 units. Any questions? Yeah, actually don't need like you leave like this is also okay. You expand, they'll give you the mark as well. So both work. Those on YouTube, aside from Adriel, who has been very attentive, any questions, guys? Okay, for part B, okay, let me see. 3 times minus 2P. 3. Because for part A, we're talking about BC, right? That is this entire highlight. Start to end is the whole thing. Then if you are looking for TC, which is a fraction of the whole thing, it's just the green part, it cannot be 3 times the whole thing, right? It's smaller than that. And the reason why it's 2 over 5 is because the green is 2 out of 5 of the yellow. Chu Ying, does that make sense? We're looking for TC is only 2 units, ma. The whole thing is 5 units. Like this whole pink line is 5 units. Part 1, not minus 3 cube. Okay, so plus 2P, because you see my start point was B, correct? My end point was C. So VQQ SLV, if you're ever confused, just take it slow, write your start and end point. We must follow the path I have drawn in red. We go left, then we go right and up. When we're going left, it is minus 2P, not plus 2P, because plus 2P is pointing right. We want to go left. So we need to take the negative of that. Remember negative vectors? So we take minus 2P to go left. Then when we want to go diagonal and right, we plus 3Q, because the arrow here is pointing where we want to go. So we can just plus it. Don't need to take the negative. So SLV, is it okay? We just follow the arrows lah. Then if you want to go to the opposite direction of the arrow, we add a minus. Awesome. So guys, for part B, does anyone have an answer? And is anyone completely lost? Thumbs up if you have an answer. Cry emoji if you're completely lost. Okay. Those who have answers, what do you get for part B? So let me just erase everything. So basically, we were thinking of taking the longer instead of shorter path for part 1. Because you see, part 1, BC, right? This is a shorter path, okay, but we don't have any values along this line. So we have to take a longer path, going left and going up, because we have these values of 2P and 3Q that we can play with. Okay, so those who are struggling with question B, I want you guys to think, what is point R? So figure out where point R is on AC. So that triangle ABC is similar to RTC. So ABC is the whole thing. Where exactly can we have a point R that we form a similar triangle to ABC? So again, we want to make a triangle that is similar to ABC, where can we put point R to make such a triangle? So think about it. In 20 seconds, I shall review where point R should be. Okay, wait. So R is a point on AC lah, so it has to be somewhere along AC. So grand review, point R should be about here, opposite the point T. So about here lah. Why do I say it here? How do I know that point R is here? Because when we do this, we have R, T, C. Can we see this is a smaller version of the big triangle? So RTC, it will be this. The big triangle is in green, right? This whole entire massive triangle. Can we agree that they are similar? RC is half. Wait, RC is half times 3Q. No. RC is not half of 3Q. No, it's not half. So, how do I know the ratio? This is not 1 unit, because see, it doesn't even look right. And how do you know it's half? What I know is that, okay, let me redraw this. What I know is that CT is 2 units and TB is 3 units. Remember, this whole thing will be 5 units. And now let's think about our topic about similar triangles. Do you all recall the length ratio of similar triangles will all be the same? Right? So if that is 2 and 3, what is the ratio of this CT, ACR to RA? What's the ratio here? This ratio of blue to green. Exactly. Yeah, lah, easy, right? Actually, you need to realize, okay, similar triangles, we can know this is 2 units, this is also 3 units. So what is RC then? And again, this whole thing now is 5 units lah. The whole entire AC is 5 units. So now we know, okay, RC is 2 out of 5 of AC, right? So RC, 2 over 5 AC. Because you see RC, same direction as AC. The vectors are the same, it's just different length, different magnitude. So the scalar multiple is 2 over 5. Remember what we learned about the scalar multiple? It'll stretch a line. Same direction, but it stretches or becomes smaller. So actually 205 AC is equal to 205 3Q equals to 6 over 5Q with the squiggly lines. Any questions for this, guys? Because, okay, Zhu do you know why I know that it's 2 units to 3 units? Do you know where I got this from? Yeah. So if this is 2, this is 3, then can we agree that the whole line will be 2 plus 3 equals to 5 units? Kind of makes sense, right? That's why I can say, oh, actually RC is just 2 over 5 of AC, which is the whole line. Oh yeah, you're correct. RC is 6/5 times the Q. Because they are similar triangles. So don't focus on this. We first see that the yellow and green triangles are the same. So this is the yellow again. Let me highlight the whole yellow. If this is 2 units and this part is 3 units, we know the ratio of this other side is 2 units to 3 units. That's why I can say that, oh, the total will be 5 units lah. Yeah, so I'm just basically comparing similar triangles, like similar to, let's say, a question like this. This is 2, this is 3. We know that the left side will also be 2 to 3. Then I know that the length ratio of x to will be 2/5. Correct? Do you think does this make sense? Okay, so next part, a little bit more tricky. Does anyone have an answer for C part 1 or C part 2 yet? The rest of y'all, don't worry, just take maybe 2 minutes to, okay, 3 minutes to try C part 1 and 2. Okay, excellent, yes. C part 1 is 4/25. How about C part 2? Anyone has it? Okay, if not yet, then y'all just give me a thumbs up when you're done with both C part 1 and 2. I'll go through and most of you are done. Okay, who is done with C part 1? Can I have some thumbs up if you are done? Okay, the rest? Anyone else done? Okay, so the correct answer is 4 over 25. So RTC is the yellow, ABC is the green triangle. The length ratio to the length of green equals 2 over 5. So the area is 4 over 25. A second one is not 4 over 25. Does anyone have a different answer for C part 2? This is a really tricky question. So have some time to think about C part 2. If you have a different answer from 4 over 25, let me know. Or if you're done with the question, give a thumbs up. Are you guys lost for C part 2? Oh no. Okay, don't worry, it's a tricky one. So I'm going to invite everyone to turn your page around. So if you printed it, turn your page around. If you are on an iPad, you can also flip it. I'm going to flip my screen too. I think it'll make it easier to look at the question. Okay. So I flip my thing around. I'll go through in like 30 seconds. Should I go through now, guys? Okay, one person wants me to go through. How about the rest? Do you want more time or would you like me to go through? Yeah, I'll go through. Okay. So now we're looking at the yellow and green triangles highlighted here, right? RBC is the yellow one, the smaller one. ABC is the big one. So if you look at it from this angle, can you notice that actually, right, the height of the yellow triangle is like this, right? Let's say, yeah, it's about there. Then the height of the green triangle is also like this. Can we tell that, hey, actually these two have the common height? Do you see this? Right. So if we know that they have a common height, then remember what we did just now? The area ratio is just the base ratio. So base is RC for this, and the other one is AC. Therefore, the ratio is 2 to 5. This is just the area ratio. Any questions? Are you guys okay? Yeah, thumbs up if you want me to carry on. Otherwise, let me know your questions. Yeah, so it's a bit hard to see, lah. But basically, these two triangles have a common height. So we apply what we learned earlier. We can just use the base ratio, the ratio of the bases. Okay, now I'm gonna flip my thing back. Okay, last part. Let me add another page. Triangle ASB has the same area as SBC. Find SB as simply as possible. So find where point SB might be. Okay, where point S might be. So take note, S is a point on AC. I think the question should be stating that also. S is a point on AC. So just now R was here, right? This is not S. You need to find a new point S. Where ASB has the same area as SBC. Somewhere along this line AC. Opposite B. So where's that? Like here? Mm, so if you think S is here, then SBC and SB. No, they won't have an equal area. Because let's say this is the base, right? Then the height of this triangle will be like this. The height of this triangle will be like this. So it's not the same. So think a bit. I'm going through in less than a minute. Okay. S is a midpoint on AC. When you put S as the midpoint of AC, agar-agar around here, then look at what you get. You have two triangles which are equal in the area. Because remember how the triangle looked when I flip my page. This was the base, right? Can we see that they still have a common height here? So if we put S directly in the middle of AC, then you get base 1 equals to base 2. Since height is the same, area ASB equals to area SBC. Does this make sense, guys? Logical, right? If base the same, height is the same, then your area will definitely be the same. So we know, okay, S should be in the middle there of AC. So how do we find SB then? Which is this purple line here. SB. So again, we start at point S, and we're ending at point B here. What pathways might we want to take to get to from S to B? SA to BA. Excellent. Yeah, spot on. SA to AB. So it will be this red path here. SA, then AB. So excellent. SA is equal to what? What is SA, guys? Oof, almost. Almost. 2P, no, not really, I think. What is SA minus half? Huh? So what do we have? We have 3Q, right? 3Q is AC. So we want half of 3Q and the negative of that because we need to flip direction. So SA equals to minus AS plus AB. Minus AS is half of AC, right? Because S is a midpoint plus AB. So this is equal to half 3Q plus 2P. Final answer, minus 3 over 2Q plus 2P. So, I know you all know that S is the midpoint, so therefore half, right? Half of AC. But I must remember, what even is AC? AC is actually 3Q, right? So remember, AC is 3Q. So SA will be minus 3 over 2Q. Why is it minus 3 over 2? Because it is half length, opposite direction. That's why it's minus 3 over 2. So thumbs up if you guys got this question. Or if you guys fully understand this question. This is like as hard as a vector question might get, honestly. So if by the end of this lesson, you guys actually fully understand what I'm talking about here, you guys get how I got this is a midpoint, understand why this is the case, you are good. So before I continue, does anyone have questions? Let me see, minus 1 point. Okay, typically we don't use decimals in vectors. It's like more common to try and use fractions. So I would encourage everyone to use fractions. Okay, any other questions? Okay, I'll move on. So this is probably the hardest one of the day, maybe. So we only have 7 minutes. I'm afraid we might have to extend a bit. So I'm gonna give you guys 1 minute, try part A first. Part A is the easy one. We have done this already. So let me know when you guys get your answer for part A. Who's got an answer for part A? Ah, okay, we're almost there, guys. One last question. One long ass tricky question. Yep. 7.5. Why? Remember that magnitude is when there's this modular sign, okay? Those lines in magnitude, and we find it by taking x squared plus y squared, square root that. So in this case, very simple. AB is square root of 4.5 square plus 6 square. That is equal to 7.5 minutes. Now for part B, really not easy. Y'all can try it for 1 minute first. I'm gonna slowly draw out a sketch for part B. So let's say a question on rhombus or parallelogram. My tip is to sketch it out. Sometimes it's helpful. Actually, most of the time it's helpful for vectors. Maybe 2 minutes for this question from now. So about 3:57 I'll go through. Must use like something bisector. Not really. So how about you, Harish? How about you draw a sketch? Try and visualize it. Okay, y'all can fill in the poll for this question. Small typo, I mean give me a bit more time. So I know where you guys are right now. So if you want me to go through, you can put I'm lost also. Okay, maybe a bit more time. Oh, who's got it? If anyone's confident in your answer, you can put it in the chat. Okay, 6 over 4.5. No, that's not the answer. So, okay, who wants me to go through this question now? Okay, one person, Chuying, Natalie, Sharifa. Okay lah. I think I'll go through now. So this is, wow, really quite a tricky question, but you need to recognize a few things. Firstly, it's a rhombus, right? So first thing you must know, all sides of rhombus are equal in length, correct? So if we know that the magnitude of AB is 7.5, that means I'm saying that this length here is 7.5 units. Any disputes? No, right? Because they're all same length, what is the length of BC? Length as in magnitude. Also 7.5. Then now, take note of what the question said here, which I'm highlighting now in blue. So you see my sketch, D is on the right of A, and another thing, it is parallel to the x-axis. So see here, BC parallel to AD parallel to the x-axis. So when I'm looking at vector BC, what is the change in y value? Is there any change in y value? Okay, so yes or no? Is there any change in the y value? No, right? Anyone else? Anyone thinks yes? Who agrees that there's no change in the y value? Thumbs up. Okay, so no change in y value. That's correct. So if the length is 7.5, and think of this as a graph lah. Let's say your graph paper, right? You have your x and y. I'm telling you the line is 7.5 units long. It is horizontal and there's no change in y value. What is the change in x value? So imagine your graph paper lah, right? I'm saying this line is 7 units and it's horizontal. What is the change in x value? There's 7.5 units long. What is the change in x value? 7.5, exactly. So there you have it. You know the change in x is 7.5. We know the change in y is 0. So if I want to express this idea in a column vector, what is the column vector? BC equals to x over y, right? X is 7.5, y is 0. So actually, BC is 7.5 over 0. Any confused, lost people in this call? Quite insane, right? It's a little mind-blowing, especially for O levels, but this is a very good application question for vectors. So I think you all should start this. Make sure you really understand how vectors works. Okay, yeah, so first thing, can we agree that the length of BC is 7.5 units? Do you guys understand why it's 7.5 units long? Like the magnitude is 7.5. BC, length 7.5. Then now let's think about our graph paper. Like, in school use the graph paper, right? Then I'm telling you, okay, this is a graph. There's a line. The line is horizontal and its magnitude, so like the length, is 7.5 units. Can you tell me the change in the x value? There's no change in y value, right? So it's not like it's a line like this. It is just a flat straight line. What is the change in x value? It will also be 7.5 units, right? So it will be 7.5. And after all, you can think about vectors as lines on a graph paper. So if BC has a change of x units on the axis, and there's no change in the y units, means the vector is 7.5 over 0. Because remember, 7.5 is like your change in x units. 0 is a change in y units. DR in Osaka, Japan. Does it make sense? Okay, excellent. Anyone else a bit confused? Okay, very good. You all learn quite fast. Very, very good. So yeah, that's how I got BC. So the next part, let's try and find. Yeah, it's really a hard topic. And no worry, this is on the harder side. It's definitely on the harder side of vectors. It's a quite tricky question. The next part is finding vector BD. So this is maybe a bit more straightforward. So vector BD on my little sketch here will be this line. Okay, this line in purple. How do you find vector BD? What values do we know? What path we want to take? So give me a thumbs up when you get an answer for 8C, and I'll go through it. BC, CD. So you want to use BC and CD. Okay, so what would your final answer be? Two ways you can look at it, right? You can use BC and then CD, or use the other path which I'll highlight now, BA to AD. Both work. Let's say I use BA plus AD. Do we have these values? How can we get these values? Yeah, I'll just wait for you all to give your thumbs up when you're done. I think I've been yapping too much. My throat's a bit sore now. Okay, excellent. What is your answer? Let's see. That's right. Very good. So maybe you can look at the next part. I'm gonna give the rest like 1 more minute, I think. So the answer is 3 over minus 6. Who's lost? Anyone lost? Anyone else done with the question? Yeah, I'll go through. So BA plus AD. What is BA? It is basically just minus AB, right? Remember the question here told us what AB is? Then what is AD? So AD is equal to BC because they are parallel. It's a rhombus. They're on opposite sides, they're parallel. And since the length is the same, the magnitude is the same, right? They are in the same direction, they're parallel. They are actually equal vectors. So AD is equal to BC as they are opposite sides of a rhombus. Therefore, we can combine these two. Oh wait, yep. So 3 minus 6 is the final answer. So we need to recognize that BC and AD are actually the same as vectors because same magnitude, same, oh they are okay, parallel. So same direction. And this is because they are opposite sides of rhombus. Okay, last part, finding an equation of a line. So just a quick refresher of your functions or your equations. How do you get an equation of a line? First step usually is to find your gradient, which is your m value, right? So y equals mx plus c is your equation. We find gradient, then we can find the y-intercept, which is your c. And we do this by subbing x, y values and m into y equals mx plus c. Then your last step will be to form the equation, itself. So feel free to drop your answer once you're done with this question, so I know when to move on. Those on YouTube, do you have any questions? The part C, which part of part C are you confused about? So, this very first part, do you get this? How I know that BD is BA plus AD. Okay, then how about the second part? Do we understand why BA is minus AB? BA is minus AB, right? Oh, okay. Because remember, negative vectors. What is BA? BA, oh yes, I'm going to send a work solution for the worksheet. BA is, hey, let me use a different color. BA is this green line going down. AB would be the same green line, but going up instead, right? So, okay, let's see here again, BA. BA is B going to A lah, right? Then if I want to do AB, so actually, remember negative vectors. Just now I went through it. BA is always minus AB. Remember? Because they are actually the same thing, just in opposite directions. Does that help you? Are you a bit more clear now? Yeah, so actually we are just going against the arrow. And remember, when we go against the arrow, we must add a negative sign. Because we have the value of AB, which will be going up. We don't want AB, we want BA. So I'm saying I want to go down instead. So I can go right. But to go down, I need to take the negative of AB. Whenever, guys, we are swapping the direction, we want to move in the other direction, we need to add negative sign. That's why the direction of the arrow is super important. Any other doubts of this question? Part C? Dia, is it okay now? Okay, that's good. So now I'm gonna go through the last part. I'm gonna move a bit faster because of the time. So we have a line that is parallel to BD and passes through a point 37. Find the equation of the line. First thing, find gradient. What is the gradient of this line? Someone let me know. Did anyone get a gradient? Who here doesn't know how to get a gradient? So the gradient of the line is equal to the gradient of BD, right? Since they are parallel. So what is the gradient of BD, guys? Think about it. What is gradient? After all, gradient is just change in y over change in x. So from this, can someone tell me the gradient of BD? Vector BD? Anyone? Just let me know. Minus 1 over 2. Almost there. Change in y over change in x. We need to remember that this, right? This is x over y. So change in y over change in x will be minus 6 over 3. So don't forget, this is x over y, right? 3 is x value, minus 6 is the y value. So the change in y is minus 6, change in x equals to 3. Therefore, gradient is minus 2. Next part, how do we find the y-intercept? I would sub my values in, right? So I sub the point equals 3, y equals to 7. 7 equals to 3, mx, right? M times 3 plus c. C therefore will be equals to 7 plus 6. C equals to 13. So forming the equation now, if I have m and c value, I can form the equation with y equals 2 minus 2x plus 13. That's my answer. So take a while to digest this. When you all are ready to move on, give me a thumbs up. Okay, nobody ready to move on? Are you guys lost again? It's quite tricky, I know. Okay, anyone else ready to move on? Okay. Okay. Okay, there are no further questions. We're almost there, guys. Last part. So, part E, the diagonals of the rhombus intersect at point P, and you have this D, which is 5 minus 2. So whenever they give you a coordinate, I want you to realize that this means that OD is 5 minus 2. So they give a coordinate, you must know how to see it as a vector. So if it's a point, then it's always OD or OA or whatever. 5 over minus 2. Now we want to find OP. Let's refer back to my little graph. Okay, so you can refer this. Now there's a point P here where the diagonals intersect. And we want to find what's the question asking for? Position vector of P, which is OP. So how do we get OP? So again, just give me a thumbs up when you're done with this question so I can go through. And we'll call it a day after this last two parts. Oh, okay, one person's done. Rachel, you're fast. Half AC for OP. What's half AC? OP? You mean AP? Think about it. Half of AC will be AP, not OP, right? You'll just be going halfway here. So Rachel's done. Anyone else done? I think I'll give you guys a bit more time. Think about it for a while. 4:23, I'm going to go through this. So we'll aim to wrap up the lesson around 4:30. Those who are done, you can try the last part. That one is a really tricky one as well. One more minute till I go through this. Those on YouTube, if you have any questions, let me know too. Okay, small intermission. So if you all found this lesson useful, this is a QR code. So you can scan it if you're interested in signing up. This QR code doesn't send you to a sign up link, it just sends you to a WhatsApp chat. So if you have any questions, just scan this as well, or direct into the chat. Then you can feel free to ask anything about our classes. Currently, I'm doing Monday and Wednesday for weekly lessons. So just be like today. So if you found today's lesson useful, you want to join, you think it's enjoyable, sign up here. If you're not sure yet, it's okay. You can just scan this first and ask any further questions or indicate interest for now. So quickly, scan if you're interested. I'm going to go through part E in a bit. Anand, Harish, do you have an answer for part E? Or Natalie, do you have an answer? Does anyone have an answer for part E? Okay, thumbs up if you want me to go through it. Okay, anyone else would like me to go through now? Okay. Yeah, I think I'll go through. It's already quite late. So OP. OP, we know we have OD already, right? So that should tell us, okay, we'll use OD. It's given in the question, we definitely need to use it. So we see we got O, and now we want to get P. So what must we add to OD to get OP? Quite simple, right? We should just add DP. Make sense? Because D will be common, so it works. And then look at the sides, we get OP. So now the question is, what is DP? So what is DP? Let's refer back to our rhombus. DP would be this green line going up. Can we see that DP is actually half of BD? Sorry, it's minus half of BD. Right? So BD, which we had earlier, is going down. We want to go up and have half of BD. So DP equals to half of BD. And actually, we got BD in our earlier question. So again, DP is equals to minus half of BD equals to 5 minus 2 minus half times BD. So BD is 3 minus 6 based on the question. Based on the part C. So 5 minus 1.5 is 3.5. Minus 2 plus 3 is equal to 1. This is your answer for OP. Any questions, guys? Thumbs up, you're okay. One last question. Wow, okay, very good. You all learn quite fast. So last part, stating your reasons clearly, determine whether a circle passing through C, D, and P can be drawn. Adro, no, you wouldn't be using, not really midpoint theorem. Yeah, so you find the midpoint of BD, but you must add a negative, right? Because you're going the opposite direction. So DP is times minus half of BD. Midpoint theorem, actually you can use midpoint theorem, but it's a bit more complicated. Okay, for the last part, C, P, D, and P. So you see, this is C, D, and P. I'm going to redraw it below. Okay, so what the question is asking for is whether you can draw a circle. Something like this. Yeah, excuse my poor drawing, but something like this lah. So I'll go through this quite soon. It's quite a difficult question. So like maybe 1 more minute, I'll just go through. How do we know that you can draw a circle here? So a hint is think about your properties of circles. Okay, I'm just gonna go through it. So since the diagonals of the rhombus intersect here, do you know that CPD is a right angle? Do you know that, guys? When your diagonals of a rhombus intersect, it's one of the properties of it. Your diagonals intersecting forms right angles here. So this is a right angle, this is a right angle, this is a right angle, this is a right angle. Who knew this? You guys probably learned it last year. Maybe some of y'all this year, but y'all probably learned this in school in the previous chapter. So if this is 90 degrees, is there any property in circles that you will think about? What property could it be? Is there any property that you guys think about when you hear about a right angle in a circle? Do you know this is 90 degrees? Ooh, tangent perpendicular to radius. True, yeah, but then in this case there's no tangent, right? So yes, exactly, angle in a semicircle. So because of this property, when we know that CPD is 90 degrees, we can conclude that a circle can be drawn. So I'll write it as such. Hence, by right angle in a semicircle property, ah, yeah, so actually this is CDR, this would be your diameter. So hence by right angle in a semicircle property, a circle passing through very long CDP can be drawn. And then you just take note, CD is the diameter. So don't need to write the last part, but you just note. Okay? Who here is confused and who here gets it? Let me make a poll just to check if you're okay with this. So before you can call it a day, check my poll. Please vote so I know whether most of you are okay. Okay, one person gets it. How about the rest? You need to know two things. So you need to realize what things are. Firstly, the property of rhombus, right? Actually, there'll be a 90 degrees there. In the second part, you must recognize that there's this property, right angle in a semicircle. Because you have a right angle there, you know, okay, it means a circle can be drawn. So this is honestly as hard as vectors get for O levels. It's a very tricky question because you combine properties of circles, you also have your finding equation, and this part here, which is very tricky. So I recommend you guys start this question and try and digest it again after class if you're a bit confused. Yeah, it's okay. So let me repeat one more time for those who are a bit more confused. First thing, you must remember that the diagonals of a okay, first we look at the rhombus, A, B, C, D. And remember, point P is in the middle, okay? And point P, it is based on the question where the diagonals intersect. Right? So based on what we know about rhombus, which is this part here, the green part, when the diagonals intersect, right, there's always going to be right angles at the intersection. This one is just a property of rhombus. So if you guys are unfamiliar with this, also need to maybe recap the earlier chapters a bit. This is just a property of rhombus. I mean, yeah, sure, you can drop me a text. You have my number. It's in the chat group. I was the one that sent the worksheet and the Google Meet link. So if you have any like simple question, guys, you can feel free to text me. If there are a lot of questions, I might take a bit more time to reply, but I try and get through them today after class. So yeah, firstly, you must recognize that there'll be 90 degrees. This CPD is 90 degrees. Then you must remember the property of circle that's related to 90 degrees, right angle and semicircle. Because of this, then we know, okay, we can draw a circle passing through C, P, and D. So I think if any other questions, you can drop me a text. I'll try and reply as soon as I can. So rest of y'all, I just want to let you know again, I do weekly lessons on Monday, Wednesday. It's just like today's one, but of course, much smaller group. So if today was useful, enjoyable, productive, then feel free to reach out if you are interested in joining. So currently, I think Wednesday we only have one spot left. Monday I will be able to take a few more students. So just let me know if you're interested in joining. Any further questions, you can also scan the QR code and reach out on WhatsApp. So whether to sign up or reach out, just use the QR code. Yeah, crash courses, to be confirmed. So other subjects, they already did their crash courses. I believe they did physics, chem, and bio already. So they already did those crash courses. I think their videos are on YouTube. For other topics of math, I haven't confirmed which topic yet. So actually, y'all can leave a message in the chat. Is there any other e-math topic that you're struggling with or would like more help? Like Trigo, is that hard? Or like, let's say, data analysis. Do you guys have any specific topic? Okay, yeah. So actually vectors it's quite a similar, there's quite an overlap with that topic, right? So sometimes they do ask probability, okay, and probability and data. So that's one of the topics I'm considering. Probability and data combined, or maybe Trigo crash course. But I'll update the Telegram channel when we confirm. You guys have any questions about the work that we did just now? Before I end off, maybe 5 more minutes, you guys can ask any questions. Do you guys also have questions about the weekly lessons? So maybe like 2 to 5 more minutes. Just feel free to ask any questions. If there's no questions at all, then we can call it a day. If you want to remain anonymous for some reason, you can also drop me a text on WhatsApp. Okay, so if there are no questions, I'm just going to give a quick summary for those who are here. So materials for the lessons, just like today, I'll send you the worksheet a few hours in advance. You guys can print it or add it to your iPad, if you have an iPad. And then we'll have a lesson. The lesson is quite similar in style. We'll go through the notes again and I'll give a quick recap. Then after that, we can attempt some questions. We start with the basic questions. After that, I'll give you guys the tricky prelim questions I find. So recap. First, the basic stuff. Magnitude of vectors. 3 marks. Okay, everyone needs to know magnitude of vectors. You just use this formula. 2 marks. Negative vectors, remember, someone asked just now, right? Just remember, AB is equal to minus BA. Because they have same magnitude, which means same length, but opposite direction. So yeah, parallel, right? Just opposite direction. We can get BA by minus AB. We can get AB by taking minus BA. Sum of vectors, when you add together, we want B to be a common point, right? So like, let's say AB plus BC equals to AC. XY plus YZ equals to XZ. But let's say I'm saying XY plus AB, that doesn't work out. Must find another vector for the question to solve it. And then we can think of it as start point and end point also. So let's say we want to find a purple AC here. We can just go down the green path A to B, B to C. assuming we have those values, A, B, and B, C. That's where you can find AC. Multiples, if you are multiplying by 2, your vector times 2 in length. If you multiply by -2, it is times 2 in length, but the arrow reverses, remember? Opposite direction. Every time you multiply by negative number, you reverse the direction. Proving of parallel vectors, I highly encourage everyone to read through this again after class, because it's a very common question. It's very simple. It's another 3 marks kind of question. Collinear point is usually just the same thing as above. They just use the word collinear instead of parallel. But what they're asking for is to prove that they are parallel. And all these questions, I'll send the answers later. I'll send this worksheet later. And I suggest recapping this also, because this is what will differentiate an A1 student from a B3. Honestly, this is the kind that a lot of students will get confused by an exam. So go and recap. I think that's all for today. So if there are no further questions, you can feel free to leave the comment. Hope today's class was useful. I'll also send this for the QR code if you guys haven't scanned it. So you're welcome, guys. I hope it was a good lesson. You guys learn more in 2 hours than like 1 month in school. Because for some reason, I don't know, teachers can't really teach vectors well, I feel. Also, if the lesson was too fast and you need clarification, just let me know. Because I really tried to cover as much as I could today. Okay, so if no more further questions, I'm gonna end the meeting. Just drop me a text if you need. Yeah, don't worry. Just drop me a text if you need clarification. Just tell me which question in particular. I'll get back to you sometime later. Okay, yeah, you're welcome. I will end the call now.